So to write an equation of a function that is a quotient of two or more functions, for example, fx equals square root of x, and then gx equals x minus 3 squared. Uh, to find out the domain of fx and gx individually, which it's pretty easy to do, right? And then let's just focus on the second part B. Given that a qx is a quotient of fx and gx, so we need to write an explicit equation for qx. Basically, you just put a square root of x divided by the x minus 3 squared. So we look at it here. So that's going to be the result. And if you look at the domain, and so you just if you look at this, you don't really need to look at what are the original functions. So just look at this, and you can see the restriction on x due to the radical sign. So x has to be greater than 0. And also you need to look at the denominator, and cannot be 0. So x cannot be 3. So that's going to be the domain x greater than 0 and x cannot be 3. And then to look at the range, and from this equation is actually not that difficult to figure out. You can see the numerator is a square root. It's supposed to be positive. The denominator is something squared. It can always be positive, and it can be 0. So then you can see the number can be very, very big if the denominator is very small. So you can see the y value is going to be to approach infinity, no problem. But it cannot be negative, because positive over positive always a positive. But and also it can be 0, so because x can be 0, so that's okay. So when x equals 0, so everything equals 0. Uh, but it cannot be negative, so you don't really need to use the graphing calculator to tell you that. So you can figure out y is actually greater and equal to 0 as a domain.